Hello all and welcome back for the Math 8 Lesson 2 note video. And in this video we'll be discussing, so the chapter and section we'll be referencing in the book is Chapter 10, Section 4. And just for reference, it does start on page 402. Now this chapter, or this section, is all about reading scientific notation. Okay, so reading scientific notation. And this is important for a few different reasons. The big one being later on in your science classes, that's why it's called scientific notation. This is something you're going to have to be able to do because a lot of things in science, especially chemistry and physics, and astronomy, do rely on your knowledge of scientific notation in order to know what's going on in those classes. The mathematical reason that we're talking about scientific notation is, and this is something we'll discuss later on once we cover all the different types of numbers, but once you have all these different types of numbers, you're going to have to be able to tell which one's bigger, which one's smaller. So if you're given a number written in scientific notation, you're going to have to be able to tell, well, how big is it compared to another number, or how small is it compared to another number, okay? So just a refresher here on the basics of scientific notation, okay? So we're going to do a little definition here about scientific notation. Now, in the book, you'll notice the definition talks about integer powers of 10 and stuff like that. But the definition I'm going to give you here, and just so you know what's going on with scientific notation, when we have scientific notation, this is just a way to write very large or very small numbers. Okay, and this is where the science comes in. So examples of very large numbers you're going to have to know how to deal with. Those are going to be things dealing with maybe like astronomy, okay, or physics, where you're talking about giant distances. So if you're talking about planets and the distance between planets and stars, those numbers are very large. And if we were to try to sit here and write out exactly how many miles away one star is from another, or how many meters it is away from another, that's going to be a giant number that will probably take up the whole page here, just if we tried to write it out in what we call standard form. Same on the other side of things, very small numbers. That's what you get when you talk about things in chemistry, or uh, in physics as well, when you talk about atoms and protons, neutrons, and electrons. Okay, the distances there and the numbers that are going to be there in terms of mass and everything are going to be very, very, very small numbers. And at the same time, if we tried to write those numbers out here, okay, they would take up a lot of space, even though they're just very small numbers, because they would have so many decimal places, okay, that we'd have to worry about. So instead of writing out these big giant numbers that would take up half a page, we use scientific notation as kind of shorthand to say, okay, this is the number we have, and it will only take up a few sections of your page here. So an example of a number written in scientific notation, I'll use the one in the book, is something like 5.4 times 10 to the negative 8 power. Okay, so in this case, 5.4 times 10 to the negative 8. This is a number written in scientific notation. So the very first thing that I want to point out here is this x. Okay. Now later on, you're going to see x being used as a variable when we start solving equations and solving inequalities. But I do want to point out that the x in this case does in fact mean multiplication. Okay, so the x, it's 5.4, or 5 decimal point 4, times, and then this power of 10. So 10 to the, in this case, negative 8 power. Now, there's two other things you got to keep in mind when dealing with scientific notation. Okay, and we'll actually practice this in example one in determining if a number is written in scientific notation or not. But if a number is written in scientific notation, so this place where the 5.4 is, this first number written in scientific notation, this is what we're going to call, we're going to call the starting factor or the beginning factor. But there's something special, there's something special that has to be true about the starting factor, and that is the starting factor has to be bigger than or equal to 1, but smaller than 10. Okay, so as you notice, this 5.4, if you know how to order numbers and you know how to compare two numbers in this way, 5.4 is in fact bigger than 1. Okay, so if you wanted to know why that is, look at the ones place. In the ones place here, there's a 5. In the ones place for the number 1, it's a 1. 5 is bigger than 1, so 5.4 is bigger than 1. And you can look at it the same way with number 10. With number 10, there's a 1 in the tens place, but there's actually no number in the tens place here, so technically that's a 0. And since 1 is bigger than 0, or nothing in this case, then 10 is bigger than 5.4. Okay, so this number has to be, another way you can think of it, it has to be between 1 and 10. Okay, now I do want to say it can actually be the number 1. That's why I put in equal to in parentheses here. But for the most part, you're going to have numbers here that are between 1 and 10. Okay, once again, we talked about the multiplication here, so let me rewrite that x so it's a little cleaner. That is multiplication. And then the second part after the multiplication, so I'm going to circle this part here. This part, or the second set of factors, always has to be, so this has to be a power of 10. Okay, so what that means is having a power of 10, that means the base, what your exponent's being raised to, has to be 10. It can't be 9, it can't be 12, it can't be any other number. It has to be 10. Okay, so when it says this part has to be a power of 10, all we're talking about there is the base of your exponent here has to be 10. Now, talking about the exponent, which is what we just went over in the last lesson, the exponents here, they can be like we've just seen with positive exponents, okay? But I do want to make a note here, okay? Exponents, when we're talking about scientific notation, exponents can be negative. And what that explicitly means for scientific notation, we'll talk about that as we go forward here. When we want to write numbers in standard form, we'll talk about that. As far as just in general, with negative exponents, that's something you'll talk about in algebra, okay? And you'll figure out exactly what it means for an exponent to be negative. But in terms of what we need to know right now, just know exponents can be negative, and we're going to discuss what to do with negative exponents in the near future here when we talk about when we look at some of the examples. Okay. And then the other big thing, so before we go off this page and actually look at one of the examples, okay, the big thing with all of scientific notation is you need to pay attention to where the decimal point is. So, for example, in the number 5.4, you can clearly see the decimal points in between the 5 and the 4, 5.4, okay? But just for a little example, what if we had the number 6, okay? Well, the decimal point for the number 6, right? Some of you might already know this, but just as a refresher so everybody's on the same page, we could have 6 times 10 to the negative 8. Well, where's the decimal place on 6? Well, the decimal place on 6 is actually after the ones place. So we can actually write 6 the same way as writing it as 6.0. Okay? So it would be probably beneficial to you if you do have just a normal number here without any decimals to include the decimal in your number, because that's the big thing about scientific notation. You always need to know where the decimal is. Okay? Now, let's go ahead and look at the first example here. Okay? So the first example, okay, so a little bit of a hiccup here. So first example, okay, so let's go ahead and look at example 1 so we can see the type of questions you'll be asked on this. So example 1, they say this example has to do with identifying numbers in scientific notation. So basically this type of question is just going to give you a number and you have to tell whether it's in scientific notation or not. Okay, so that's the actual instructions here. Tell whether the number is written in scientific notation. Okay, now in the book it does say explain, but I'm going to actually explain how you can tell if a number is in scientific notation here. So, and I do have to say on the homework assignment, I haven't put a way for you to explain why. So on the homework and the practice, you'll see a number and you'll just have to say, is it in scientific notation or not? Okay. But the way I explain it here, this will hopefully explain to you how you can tell whether a number is written in scientific notation or not. So first off, part A, we've got the number 2.7 times 10 to the negative 9. Okay. So some of you guys might already look at this and be able to tell, okay, yes it is or no it isn't written in scientific notation. But I'm going to go ahead and give you 3 different questions. And if you answer these 3 questions, then that'll tell you whether or not your number is written in scientific notation. So the first question we need to ask is about this 2.7. Is 2.7, so is 2.7 bigger than or equal to 1? So once again, just knowing how numbers work and knowing how to tell if one number is bigger than the other, the ones place here is a 2, the ones place here is a 1, so 2 is bigger than 1. So yes, 2.7 is bigger than or equal to 1. Okay. The next question we need to ask is 2.7 less than 10. Okay, which I wrote the word out there. I guess you can, no harm in using the number. So is it bigger than 10 or less than 10? Well, once again, same type of thing. There's no tens place with the number 2.7. So technically, if you wanted to, you could put a 0 out here. 0 2.7, okay? And you wouldn't really change anything. But obviously 10 is bigger than 2, so that means that this number is less than 10. So we've got yes, and we've got yes so far. Now the last question you can ask, okay, and you need to ask is there a power of 10? Okay. Now once again, that's what this part right here. After the multiplication symbol, is that a power of 10? Well, 10 is the base, and it's raised to, in this case, a negative exponent, but that is fine. Once again, exponents can be negative. So 10 to the negative 9, well, yes, we have a power of 10. Okay. So if all three of those are yeses, okay, so let me split it here because we're going to look at another one here in just a second, then the answer itself is yes. This is a number written in scientific notation. The 2.7 is bigger than or equal to 1. It's less than 10. And then it's being multiplied times a power of 10. Okay? So let's actually look at an example of one that's not in scientific notation. Okay? So with this, we're going to be looking at one. So I'll go ahead and tell you the answer to this one is going to be no. Okay? But let's see why. So part B, we have 0.3 times 10 to the 12th power. So let's ask the same three questions here. First off, we need to look at this first number. It's a 0.3. So we ask, is 0.3 bigger than or equal to 1? And actually, right off the bat, we have the answer is no. Okay, 0.3, the ones place here is a 0. The ones place here is a 1. 1 is bigger than 0, so actually 1 is bigger than 0.3. So the answer to that question is no. Okay, 0.3 is not bigger than or equal to 1. Okay, so we go on to the next question. Okay, and technically we could actually stop right there, but I want to show you what happens with the other questions. So once again, always ask these same three questions. Is 0.3 less than 10? Well, 0 is less than 10, so 0.3 is less than 10. So yes. Okay. And then the last question, is there a power of 10? So is the 0.3 being multiplied by a power of 10? And the answer is yes again, okay? Because once again, we have a base of 10 raised to, in this case, the exponent of 12. But once again, we need to look at that base. That has to be a 10, okay? So we have a power of 10. 0.3 is less than 10. But since 0.3 is not bigger than or equal to 1, this whole thing is not, so it's not in scientific notation. So the answer here is no, okay? So one way you can think about it is if you ask these three questions, if any single one of them, it only takes one, if any single answer to a question is no, then the number is not in scientific notation, okay? Now, am I asking you to write down and answer each one of these questions like I have each time here? Not necessarily. These are questions that you need to ask yourself in your head. So once again, you see this number, 0.3. Is that bigger than 1? No. Well, then you automatically know this is not in scientific notation. Okay? Do we have a power of 10? If the answer to that is no, then it's not in scientific notation. And then if the number is not bigger than, or if it's not less than 10, so if we had like 15 times 10 to the 12th power, then the answer there would be no. And any one of those questions being answered no tells us the number's not in scientific notation. Okay? And those are pretty easy once you get the hang of it, and you're definitely going to get enough practice. I think I've put like non-practice questions on the practice assignment on this type of question. But once again, make sure you're answering those 3 questions. And if any of the answers are no, then it's not in scientific notation. If all of them are yes, then it is in scientific notation. Okay. So let's go ahead and talk about the next part, okay? And this is the major part. This is the main thing that we need to cover with scientific notation, okay? And this has to do with writing numbers in what we call standard form. Now, I kind of made a mention to this earlier. When we're talking about standard form, we're just talking about a decimal. We're talking about a normal number. So if I wanted to write the number 1 million standard form, I would sit here and write out 1 million as a number, okay? So this is what we're talking about when we're writing a number in standard form. So the difference of that is we just talked about numbers in scientific notation. Scientific notation. So what we're going to have to do is basically convert. If you're given a number in scientific notation, convert it to a number in standard form, okay? So we have 3, technically 2 if you look in the book. There's 2 rules, but I'm going to give you a third one that they don't give you in the book that is, something that you need to know, okay? But there's 3 rules here that you need to follow when you're writing numbers. So if you're converting from scientific notation to standard form, okay? And those 3 things are: if the exponent on the 10, so the power of 10, if the exponent on the base of 10 is positive, okay, so if it's positive, you move the decimal point to the right. Okay. Now this is something that you're going to have to remember. Okay, and I'm going to give you a little way that you can remember this pretty easily, if you know what I'm talking about here. But once again, if the exponent on the 10 is positive, you move the decimal place to the right. On the flip side of that, if the exponent on the 10 is negative, okay, so we're going to have to move the decimal place. So if it was positive and we moved it to the right, you could probably guess that we're going to move the decimal point to the left. Okay, so positive exponents, you move the decimal to the right. Negative exponents, you move the decimals to the left. So in terms of, if you're unsure what I mean by move the decimal place, if you'll pay attention and look at the next example, you'll see what I'm talking about here. But just as a general rule, positive means you move the decimal place to the right. Negative means you move the decimal place to the left. Okay. Now the third one, which they don't mention in the book here, that I did want to point out to everybody here, is if the exponent on the 10 is neither positive nor negative. So what I mean by that is if the exponent is 0, okay, so let me actually write out the word 0 here so we don't mistake it for an O while we're writing in a sentence. Is 0, okay, so that means it's neither positive nor negative, okay. If the exponent on the 10 is 0, don't move the decimal place or the decimal point. Okay, so basically the decimal point's going to stay just where it is. All right, so one way that you can think about this, okay, so everybody should be familiar with the number line. So you have 0 in the middle, positive numbers to the right. So counting up 1, 2, 3, 4, 5, 6, on and on. And then to the left, negative numbers. Well, when we're actually going through with this, think of the number line. Which way on the number line are the positive numbers? Well, they are, once again, positives are to the right. So that indicates to you you're going to move the decimal place to the right. So over here are the positive numbers. Okay, so positives are to the right on the number line. Well, at the same time, negatives are on the left of the number line. So the negatives, okay, are on the left. So if you can remember which way you go on a number line to get the positive numbers and which way you go to get the negative numbers, that tells you which way to move the decimal place, okay? Another way to think about it is if you have a positive exponent, it's going to make a bigger number, okay? So in this case, bigger numbers are to the right, okay? Whereas smaller numbers, so if you get more and more negative, that means the number is getting smaller and smaller, okay? Those are to the left, okay? And that's what's going to happen when you see the examples when we look at instances of negative exponents. Now, right in the middle of all this is the number 0. So if you're in the 0, it's right in the middle, okay? Well, then you don't move the decimal place at all, because if you're at 0, you're kind of in the middle. You don't have to go left or right at all. You're right at the number 0, okay? So like I said, if you need to, use the number line, okay? So use the number line. I'll make sure you see what I'm talking about here. Use the number line to tell you which way you need to move the decimal place. And once again, one way you can think of it is positive numbers. So positive exponents are going to give you bigger numbers, okay? So that means you need to move the decimal place to the right to make the number bigger, okay? At the same time, negative exponents are going to make the number smaller. So that means you need to move to the left to make the number smaller. Okay, and that's just a little neat way, and this is the way that I've always thought about it whenever I was taught this in grade school, is that when you look at the number line, that kind of tells you which way you need to move the decimal place. So let's now look at what I'm even talking about here. What am I even doing by moving the decimal place? Well, this is where example 2 comes in. So example number 2. And in this case, we're writing numbers in standard form. So writing numbers in standard form. Ooh. Okay, there we go, finally. Okay, so let's look at part A. They tell you to write 7.16 times 10 to the negative 5 in standard form. Okay, so they're asking you to take this number and write it as either a decimal or a whole number or whatever the number is in standard form. So that means no multiplication and no exponents, okay? So the steps that we do to do this, well, first off, we need to know, and you want to give yourself a little space here, the first number we're talking about here is 7.16, okay? So once again, give yourself plenty of space on either the left or right, and we're going to write down the number 7.16. And we need to know where that decimal point is, okay? So you can see it's between the 7 and 1. 7's in the ones place. 1 is in the tenths place, okay? So that's where the decimal goes, right between the 7 and the 1. The next thing we need to notice is the exponent. Okay, the exponent in this case is -5. So first off, we notice the exponent is negative. So referring back to our previous page here, if an exponent is negative, we move the decimal place to the left. So how do we actually move the decimal place? Well, we go, and this is the way I do it. Okay, so this is probably the easiest way to think about it. We put our pencil right where the decimal place is on the 7.16. And then, since we have to move the decimal place to the left, okay, in this case, the number 5 tells us we got to move it 5 places to the left. We're just going to put our pencil down at the decimal place, and we're going to count over, counting each place. So in this case, we're going to go 1, 2, 3, 4, 5. And what I always like to do is when I get to the end, I like to put a little arrow to tell me that's where the decimal place is going. Okay? Now, after we get done with that, we're still not done yet, because you notice we counted over these spaces, but there's no numbers in these spaces that I counted in. So the number we have to add into each one of these spaces is the number 0. Okay, so in this case, there's 4 spaces, 4 zeros. All right, and then the last thing we need to do is we need to rewrite the number. So in this case, we have a point. So the decimal is going to be here. You see we have 4 zeros. And then we have the number 716. Now, just as a good general practice, even though you're technically not wrong by saying 0.00000716, okay, I always like to put a 0 in front of my decimals if there's not a number out there to indicate that the ones place is 0. So technically we have 0.0000176 or 716, okay? And once again, that's the process that we have to go through to write a number from scientific notation to what we call standard form. So in this case, we got a decimal. This is the number in standard form. Okay, so once again, write down the number up here. So in this case, 7.16. Figure out the exponent is -5. That means we're going to move the exponent to the left 5 spaces. 1, 2, 3, 4, 5. Fill in the blanks with zeros, and then you have your number in standard form. Okay, so let's go ahead and look at part B. Okay, so let's look at part B. In this case, they want you to write the number. So write 4.3 times 10 to the 4th in standard form. Okay, so same exact process here. First off, we need to write the number 4.3 down. Okay, then we notice that the exponent in this case is +4. So once again, if we flip back to the next to last page, if we have a positive exponent, we're going to move the decimal place to the right. Okay, so what that means is, same exact thing. We're going to put our pencil where the decimal place is, and in this case, we're going to move the decimal to the right 4 spaces. So that means we count over 1, 2, 3, 4. And this right here is where the decimal place is going to go. But once again, we have a bunch of spaces here where there's no numbers. So we have to put in those spaces zeros. And once again, we're still not done because we actually need to just write the number out. So the decimal place moved from here to here. So this is the number 4, 3, 0, 0, 0. And Where the decimal place is at the end here, we technically do not need to include it. We don't have to do 0.0 or point, so 43000 point. But if you feel more comfortable, there's no problem with you doing that so you know where the decimal place is. Because if we add a 0.0, kind of like we added a 0 at the beginning of the last one, that doesn't change anything with the answer, okay? That's still the same number. It's just we're adding a 0 here so we can see where the decimal place is. And it's good practice to put the comma in there because that's 43,000 is the number. But once again, you can write it with the decimal, or more than likely you'll see it just written as 43,000, okay? And it's understood that the decimal point goes right after the ones place. So like I said, either one of these would work, okay? But that's really it in terms of writing numbers in standard form. Now, like I said, if there was a 0, okay, so let me just point out, if this was maybe like 10 to the 0, then this number would just stay 4.3. We don't move the decimal place anywhere, okay? So 4.3 times 10 to the 0 would just be 4.3. 7.16 times 10 to the 0 would just be 7.16. So we don't move the decimal place at all if the exponent is 0. But if it's positive, we move it to the right. If it's negative, we move it to the left, okay? And that's really all there is to writing a number in standard form, which is honestly the biggest thing that you're going to have to be able to know how to do coming out of this section, okay? That's the thing we're going to use the most throughout the rest of the year. But let's talk about one more example, and then this will actually be it for the notes. So let's go ahead and look at example 3. Okay. In this case, you're dealing with an example where you're comparing numbers in scientific notation. So what that means is we're going to be telling, since we've got numbers written in scientific notation, we're going to be looking at these numbers and we're going to be saying, well, which one's bigger, which one's smaller. Okay, so that's what it means to compare two things in math. When we compare things, we want to see which one's bigger, which one's smaller, or we might even have to order things. So we might have to order it from the smallest number to the biggest number, or the biggest number to the smallest number. Okay, but just to let you know of a type of question that you could see. Okay, let's go ahead and look at example 3. In this case, it is kind of like a word problem. So let me write out the information they give you. So they say the masses, and they tell you that the units for the mass is in kilograms. If you don't know what mass or kilograms are when you go to science this year, you'll learn about that in science. But main point is just pay attention to the numbers that are being written here. So the masses of 3 planets are given. Okay, so you're going to be given 3 masses here of different planets, okay? And the question is, which mass is greatest? Okay, so in math, the word greatest means essentially which one's the biggest. Okay, so in this case, out of these numbers that you're going to be given, you're being asked which one is the biggest. So the list here, we've got Jupiter. They tell you have a mass of Jupiter. The mass on Jupiter is 1.90 times 10 to the 27. And then once again, kilograms. You're told Venus has a mass of 4.87 times 10 to the 24. And then you're told Neptune has a mass of 1.02 times 10 to the 26. Okay? So, one way we could go about doing this is we could write out each one of these numbers in standard form and see which one's bigger, which one's smaller, and compare them that way. But if you look at the exponent on this is gigantic, 27. That would mean you would need to move the decimal place 27 spaces over to the right before you would get the number, standard number in standard form. Okay, so to save us from having to do that, what you can do is if you've got numbers written in scientific notation, all you need to do, okay, is look at the exponents. So when comparing numbers written in scientific notation, okay, look at the exponents. Okay, so what I mean by that is, well, the exponents here are 27, 24, and 26. So 27 is bigger or greater than 24 and 26. So in this case, since 27 is bigger, that means Jupiter, okay, has the biggest mass. So the answer here is Jupiter. Okay. Now, at the same time, okay, so we've answered this question. Once again, the exponent 27 is bigger than 24 and 26. That means Jupiter has the biggest mass. But what if they asked us for the smallest mass? Well, it works the exact same way. 24 is less than 26 and 27, so that means Venus would have the smallest or the least mass, okay? So it works both ways. If you find the biggest exponent, that'll give you the biggest number. If you find the smallest exponent, that'll give you the smallest number, okay? But there is a situation, well, what if two of these had the same exponents, okay? Well, let's go ahead and mark a little thing down here. Oh, let me try that again. Let's make a little thing down here. The bigger the exponent, the bigger the number, and at the same time, the smaller the exponent, and even talking about negatives. So if you've got a really negative number, the smaller the number. Okay, so what I mean by that, bigger exponents mean bigger numbers. Smaller exponents mean smaller numbers. But then we have the question, well, what if we have exponents that are the same? So out of these two numbers, which one would be bigger? Okay, well, let's say we had 2.56 times 10 to the third, and we have 5.72 times 10 to the third. Which is bigger? Well, in this case, you see the exponents are the same, so we can't rely on our exponents. Here, then, we have to look at the actual numbers. So since 5 is bigger than 2, that means 5.72 times 10 to the third is bigger. Okay? So if you do run into a case where you have the same exponents, then you have to look at the starting factor. So if two numbers written in scientific notation have the same exponent, you must compare the starting factors. Which once again is exactly like what I did here. 2.56 is less than 5.72, so that means 5.72 times 10 to the third is bigger than 2.56 times 10 to the third. Even though they both have factors of 10 over here, 10 to the third, 10 to the third, okay, or powers of 10, where the exponents are the same, then we have to look at these numbers, okay? But really, that's it. We are going to skip example 4, just like last time. So, for the same reasons. But that is the thing. Make sure when you're going through the practice, if you need to, come back and review this video. But this is pretty much all the information that you'll need to do the practice and do the homework. So the homework and the practice questions stem directly from what we did in examples 1, 2, and 3 here. So like I said, if you need to come back and review some of the examples we talked about here, that's what this video is for, okay? So go ahead. Once you complete this, go complete your practice assignment. And then after you complete the practice assignment, complete your homework, okay? And then hopefully with this video, you'll have everything you need to understand what to do there. Thank you for watching.